Far beyond the noise of Earth, where human signals fade into static, something unusual moves through the solar system. A third known interstellar traveler, designated 3I, Atlas, has entered our neighborhood. Unlike anything seen before, its trajectory is carrying it dangerously close to Mars, only days away from a near pass that should have astronomers shouting warnings across every platform. Instead, the opposite is happening. Official channels fall silent. Updates vanish. The usual stream of public bulletins dries to nothing. Atlas's trajectory is what unsettles experts most. Rather than the steep, random angles interstellar objects usually cut through the solar system, this one runs nearly flat, hugging the same plane where the planets orbit. Only 5 degrees off the solar system's disk, its geometry looks less like chance and more like design. At hyperbolic speed, over 61 kilometers per second, Atlas cuts a path through familiar territory as though it knows exactly where to go. And strangely, the closer it approaches, the quieter the skywatchers grow. Mars lies directly in its path, just 18 million miles from the incoming track. That's close enough for orbiters circling the red planet to capture every flicker of detail. But instead of a surge of images and science, the data streams thin out. Mars Express, the trace gas orbiter, missions that routinely share pictures of Martian dust storms, polar frost, and shifting dunes, suddenly broadcast almost nothing new. No mention of Atlas. No official recognition of the interstellar visitor now slipping past their skies. Yet, beneath the silence, the work continues. Technical logs show quiet shifts. Observation windows adjusted. Spectrometers retuned, not for Martian methane or seasonal dust, but for water vapor, carbon monoxide, and organics. Engineers slip in new coordinates, subtle tweaks, almost invisible unless one knows where to look. Behind the curtain, spacecraft are being reoriented to watch Atlas, but the public is told nothing. At closest approach, the comet-like visitor will blaze past Mars faster than any probe we've ever launched, its coma and tail bright enough that even small telescopes on Earth could catch it, if they were pointed the right way. By contrast, the last interstellar visitor, Borisov, never came within 150 million miles of a planet. Atlas is threading a corridor so narrow, so deliberate, that some orbital specialists privately call it mission-like. But silence dominates. Professional astronomers who normally rush to share discoveries are absent from conferences and press. Amateur observers, those restless skywatchers who once filled Discord and Telegram with late-night images of every faint comet, complain of data droughts. It is as if the entire astronomical community has been instructed to look away. The story began months earlier. On July 1, 2025, an automated survey in Chile flagged a faint object streaking across its scans. Within hours, orbit analysts realized it didn't fit any known solar system body. Archival images from mid-June confirmed it had been visible all along, hiding in plain sight. The calculations were swift and decisive: eccentricity greater than 1, inbound velocity of 58 km per second, hyperbolic orbit. Most interstellar objects slice into our system at steep angles. Atlas, however, slid in nearly flat, clinging to the ecliptic like a spacecraft threading planetary orbits. Mars, Earth, Venus, even Jupiter, would each line up along its projected corridor. Simulations revealed how rare this was. Out of thousands of modeled entries, fewer than 1 in 500 would align this way by chance. Tracing its orbit backward left no doubt. It was not bound to the Sun. It came from the galactic field, unbound, unknown, and never returning. Then came the behavior that defied cometary science. At a distance of 6.4 astronomical units, far beyond the frost line where solar heat is too weak to melt ice, Atlas began to glow. Its brightness rose in bursts, then faded, then rose again. A pattern more like a heartbeat than steady sublimation. Hours-long pulses of gas and dust, followed by silence. Nothing in the physics of comets predicts such rhythmic activity. Its tail deepened the mystery. Instead of streaming cleanly away from the sun, parts curved in odd directions. Segments bent forward. Clumps of dust lagged behind. Spectra showed that the tail was composed of heavier, slower grains that shouldn't have been able to escape at all. Some theorists suggested magnetic fields, others exotic chemistry or buried jets. No one agreed. By the time Atlas neared Jupiter's orbit, its activity was already rewriting cometary science. Its dust and gas output was far beyond what a nucleus its size should ever sustain. If the core truly measured only 6 kilometers across, it was hemorrhaging material at a rate that no model could explain. Some scientists proposed that it was larger than imaging suggested, closer to 10 kilometers, hidden beneath its dense coma. Others argued it was fragmenting, splitting under its own volatile pressure. And a smaller, more daring camp wondered if it contained vast reservoirs, internal chambers of material unlike anything we had seen before. The world's most powerful observatories took aim. The James Webb Space Telescope turned its infrared spectrometers toward the object, searching for interstellar organics and silicates frozen before the birth of our solar system. Hubble snapped high-resolution images of its shimmering coma. Both saw the same unsettling truth: the volume of material leaving Atlas dwarfed what its nucleus could possibly supply. It was not just a comet shedding ice. Something more was happening. Something beyond standard physics of dust, gas, and sunlight. Yet as the data piled up, a second stream of evidence flowed, not from official channels but from amateurs. From backyards and desert ridges, from South Africa to Chile, from the Australian outback to rural Europe, coordinated teams tracked every flicker of Atlas's heartbeat-like rhythm. They logged sudden outbursts and brightness jumps, sometimes hours before professional alerts appeared. Discord channels buzzed with raw images, calibrations, and debates. For a brief time, ordinary skywatchers became the world's most transparent eyes. But that openness would not last. As autumn drew closer, the windows narrowed. Hubble and Webb entered solar avoidance protocols, turning away for safety. From Earth's surface, Atlas slipped into the glare of the sun, impossible to see against its blinding background. Only a handful of machines, Mars orbiters and solar observatories like SOHO and Stereo, remained in position to glimpse its path. And that was when the silence deepened. By late September, preprints vanished. Conference talks that once welcomed the public locked their doors. Internal memos circulated with stamped warnings, embargo, and operational security. Leaked fragments hinted at anomalies, strange spectra, unexplained particle flows, redacted before wider audiences could study them. Proposals to redirect spacecraft, like Juno or even Earth-based radar arrays, were quietly dismissed. Among scientists, conversations shifted into coded language, vague allusions, and private channels. Then October came. And with it, the blackout. Atlas disappeared into the sun's glare, invisible from Earth for nearly 2 weeks. For the first time since its discovery, humanity lost direct eyes on the interstellar visitor. The steady stream of observations collapsed into silence. Mars orbiters scraped what they could, while solar observatories strained to capture indirect glimmers. But the resolution was poor, the data incomplete. Humanity's best tools had gone blind at the most critical moment. October 31, 2025. Perihelion. The day Atlas skimmed closest to the Sun. At that point, arguments among astronomers had hardened into camps. Some insisted the nucleus was no larger than 6 kilometers. Others pushed for 10 or more, citing its immense outflow. Each camp envisioned a different fate. 1. Fragmentation. Atlas breaking into shards, its secrets revealed in a scatter of fragments across its orbit. 2. Collapse. A violent, singular outburst, a death throe as its volatile heart gave way. 3. Survival. The most unlikely, but also the most unsettling, that Atlas would endure intact, unchanged, continuing on its precise, mission-like path. Mainstream science points to exotic ices, rare chemistry, interstellar dust. Yet a minority whispers another story, that the heartbeat pulses, the uncanny coplanar trajectory, and the deliberate corridor through the planets all suggest intent. Not randomness. Not chance. A visitor, not just drifting, but navigating. And yet, silence. For now, the truth is buried. Hidden in the sun's glare. Locked inside embargoed archives. Waiting in data streams not yet released. Whatever Atlas is, comet, fragment, or something engineered, it has already exposed the limits of human science, and perhaps more importantly, the limits of human openness. It has shown how quickly transparency can fracture when the extraordinary looms too close. The interstellar object has come and gone. Its story, however, remains unfinished. The answers to what truly happened at perihelion, whether Atlas broke apart, exploded, or survived intact, remain unresolved. The final truth lies waiting. Somewhere in a server vault. Somewhere in encrypted signals. Somewhere in the future, when the silence finally breaks. Until then, the question lingers in the void. Was 3I, Atlas just another comet? Or was it a message written in motion?